Today we'll be learning lesson 5.5, using congruent triangles. So the goal is to show corresponding parts of congruent triangles are congruent. And again, so far this chapter we've learned quite a few ways that triangles can be congruent. For example, down below here we've had side, 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 abbreviated SSS, side, angle, side, angle, side, angle, ASA, angle, angle, side, and hypotenuse leg, sometimes referred to hypotenuse leg right triangle, right? So with all these, what's the point, right? The point is these were shortcuts to showing triangles congruent. Normally, to show a shape congruent, we need all angles congruent to all angles in the other corresponding one, and all sides of one, say, triangle congruent to all sides of the other, right? But as you can see, in some of these, due to some higher level math, we might only need 3 sides or 2 sides and an angle. So because of that, what we can do is we can use these shortcuts to show that triangles are congruent, and then we're going to use that, right? Because now we can use that to say, what about in the hypotenuse leg? We can see those other angles that that we didn't know were congruent are now congruent. So that's where this lesson is kind of pointing us to. So for example, if we know triangle ABC and DEF are congruent, then we know all these pieces are congruent. All 3 sides are congruent, all 3 angles are congruent, and so on over here, right? Right, so we've got all that information. Now, again, we only needed side, 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 and then we knew all angles were congruent. Or angle, side, angle, and then we know the other angles are congruent. So that's the kind of point of what this lesson is going to. And once we know triangles are congruent, then we can do anything with the other sides or the angles that we didn't have and know that then those are congruent based on what congruent triangles mean or congruent shapes. Right? In the diagram, M is the midpoint for both AB and CD, and it's asking us to show that angle A and angle B are congruent. Now this information here is not going to give us angles are congruent, right? Midpoint means it is a point in the middle of a segment such that, for example, for AB here, right, if M is in the middle, that means AM equals MB. And if M is in the middle of CD, it means that MD is equal to MC. Right, now notice those are 2 congruent marks. But now that's only 2 pieces, whereas my third is a reminder, if your vertices, we've got a vertex right here that is touching the vertex of the other triangle, this will give us vertical angles, right? So AMD and CMB are vertical angles, and therefore those are congruent. Now we have side 1, angle 1, side 2, which is congruent to the other triangle of side 1, angle 1, side 2. And so these triangles are congruent to give us side, angle, side, right? Triangles congruent. Now, we aren't doing proofs, but what we are doing is kind of looking to see how can we know that those angles are congruent. Well, now that the triangle is completely congruent, right, technically we can make this statement. Right, how I like to do it is side 1, angle 1, side 2. So AMD, triangle AMD is congruent to triangle, and now I'm going to go down side 1, vertical angle, side 2. That AMD is congruent to triangle BMC. And now based on this statement, I can get congruent angles. From that statement, we can use that corresponding parts of congruent triangles are congruent. This is basically saying, by definition of congruent triangles, right, because now we have triangles congruent, by definition of congruent triangles, angles A and B should be congruent, or are congruent, actually. Moving on. Sketch the overlapping triangles separately, mark all congruent sides and angles. Now the overlapping triangles I'm kind of hinting at here is this triangle here. There's one triangle, and then here's the next triangle. Right, so we want to sketch those separately and then label them, because they may have some things already. So we've got JGH, and the other triangle, KGH. And then labeling what we have. We've got a congruent angle here, congruent angle marked here. And over here we've got this one and this one. So right now we have angle, angle. Now our third one is, notice we use GH for this side, for both of them. This side overlapped. So it is reflexive, equal to itself. We don't need two congruent marks, just one. And so now we have angle 1, angle 2, side, angle 1, angle 2, side, for angle, angle, side. So tell what theorem you can use to show they're congruent. That theorem is angle, angle, side. Right? Now, some cases it is easier to draw the triangles separate and figure that out. Because of the overlap, some people might miss that these parts are important, or alternatively, they might think that, oh, we got these vertical angles here, but those aren't the triangles we're talking about, right? We're talking about JGH and KHG, right? So that's why you got to be careful with your diagram. Next, we're given ABC and DEC are congruent. So I'm going to mark it up here. ABC is this one, DEC is this one. And CB is congruent to CE, right? This statement here. CB, CE congruent. Now it looks a little bit like a diamond. Show the triangles CAP and CDE are congruent. And then AB is going to be congruent to DE. So how can we show that? Right? So this is another one where it may help to draw them separate. Again, if we highlight it, you might be able to see here that we've got this triangle with some congruent pieces. And then in blue, we've got this triangle with some congruent pieces. Now you'll notice using blue and yellow, we get a little bit of green for the overlap. But where that's actually important is we have reflexive in a place we typically don't have. Right? We see a lot of reflexive sides, but here we have a reflexive angle. Angle C is in both triangles. I try to draw these out separately. Not the best at drawing these types of triangles, but try my best here. Right? We've got these triangles where we share this angle. E is congruent as well. So over here, drawing this one, triangle ABC and DEC. There we go. And we've got C is used in both, and B and E are equal angles. But we've got, lastly, one side. So how can we show the triangles are congruent? Angle, side, angle. Angle 1, side 1, angle 2. So this is an ASA congruent, so that the triangles are congruent. Right? We've got ASA triangles congruent. And then we can say AB and DE are the sides that would be in the same position. So those are congruent based on triangles are congruent. Right? So we needed to know that these triangles were ASA congruent before we could say AB is congruent to DE. One more example. What congruence postulate or theorem would show that AB is congruent to CD? Now again, this is a combination, right? We want to talk about which of the three letter methods is it. This is what they mean by postulate or theorem. Right? We've got all these options for you. Right? Which one of those? And then we're going to use the corresponding parts of congruent triangles congruent, right? The definition of triangles being congruent to finish it off. So right now we've got one set of side congruent, and these little triangles here mean they're parallel. We also have a shared side, right? One of the key things to look for in a diagram is the shared side, and the other thing to look for is vertexes touching for vertical angles. Now we don't have just a vertex touching because we've got a reflexive this time. But so far we've got side, side, and we need an angle. These parallel sides are going to give us an angle because these two angles here are related. They're one of our corresponding alternate interior or alternate exterior, right? So sometimes it helps to extend the lines. And once I do that, once we extend these lines, here's the interior. So it's not going to be alternate exterior or corresponding because both angles are on the inside, right? Is that alt exterior corresponding? I'm going to say alt in. So it's got to be alternate interior. So our alternate interior angles are congruent, right? So alt int angles are congruent. And now we have side, angle, side. And over here, side, angle, side. So we've got SAS is our one that we're using this time. And then with that being true, then we know that this top side of the triangle is congruent to the bottom side. I need 3 marks now, right? Because once the full triangles are congruent, all sides are congruent. And that wraps up today's lesson. Homework can be on the next slide. And you'll have the remaining work time to work on it while the other class is testing.